Alright, let's take a second to review significant figures. We've talked about significant figures in making our own measurements when dealing with uncertainty in measurement, but we have yet to talk about if we're looking at someone else's measurement. How do we determine if their numbers are significant to us? Well, we have a couple of rules. We call this counting significant figures. In counting someone else's significant figures and counting significant figures on a measurement, we count all numbers except for two types. The first one is leading zeros. If a number comes at the beginning, or if zeros come at the beginning of a number, we never, ever count them as significant. We still have to have them because they're placeholders, they're just not significant to us. The other type of zero that's not significant to us is a trailing zero without a decimal point. If they're at the end of the number, they're not significant to us. They are just placeholders. If a scientist does want to make that number significant, he would put a decimal point after it. Let's look at some examples. All right. The first one. All non-zero digits are significant, so we've got 1 sig fig, 2 sig figs, 3 sig figs. Now this last zero, it is a trailing zero, but it has a decimal, so we count it as significant. In number 2, we have no leading zeros, we have no trailing zeros. So all of these digits are significant. We have 3 significant figures. Alright, the last, number 3, we have a trailing zero. It does not have a decimal, so this zero is not significant. So we have 1, 2, 3 significant figures. And in this last one, number 4, we have leading zeros. Leading zeros are never significant, but we also have a trailing zero. Now, this trailing zero is significant because of this decimal. Think of it this way. If a scientist goes through the extra effort of putting a decimal point and then zeros behind that decimal point, it's probably going to be significant because most of the times in math we just leave those off. Rounding rules. Look at the number behind the one you're rounding. If it is 0 to 4, you leave it the same. If it's 5 and up, 5 to 9, you go up to the next number. So let's look at an example. If you round 45.462 to 4 significant figures, so 1, 2, 3, 4, this 2 makes this 6 stay the same. If you round this number to 3 significant figures, 4, 5, 4, 6, this 6 makes this 4 go to a 5. To 2 significant figures, 4, 5, this 4 makes this 5 stay the same. If you go to 1 significant figure, the 5 makes this 4 go up, and you get 50. Now, is the 0 important? Yes, it's important. We have to have it because 50 is not the same as 5. But is it significant? No, it is just a placeholder. When calculating with significant figures, the easiest rule is when you multiply and divide, and that's most of what we do in chemistry. The number with the fewest number of significant figures determines the number of significant figures in your final answer. So let's look at an example. If I ask you to multiply this in your calculator, 13.91 grams per cubic centimeter times 23.3 grams per cubic centimeters rather, you get this number in your calculator. But we can't use all of those numbers. We have to look at the number of significant figures. So if we look at this first measurement, there are 4 significant figures. If we look at our second measurement, there are 3 significant figures. Our final answer can be only as good as our least precise measurement. So our least precise measurement has 3 significant figures. So our answer must have 3 significant figures. 1, 2, 3. We have to round the rest of the numbers so the 1 makes the 4 stay the same, and we end up with 324 grams. When adding and subtracting with significant figures, it's a little bit different. It's the number with the lowest or the least precise place value determines the place of the last significant figure in the answer. So let's look at it like this. It's always easier to line them up in column form. All right? The least precise place value in this top number is the hundredths place. the least precise place value in the bottom number is the tenths place. So our final answer can only go to the least precise place value, which is the tenths place. So our final answer, we would have to round to 7.8. That 5 makes that 8 go up to a 9. Our measurements can only be as good as the least precise measurement. Our final answers can only be as good as our least precise measurements. Let's take a look at this example. The least precise place value in the first, or in the top number, is the 4. In the bottom number, it's the 3, because remember, this 0 is not significant. Trailing zeros are not significant unless there's a decimal. There's no decimal, so this is not significant. So the 3 is our significant place. So our answer must go to the tens place. So rounded, this will be 350 because that 4 makes that 5 stay the same. Remember, if you do not have units on the test, you do not get credit. Calculating with significant figures. Exact numbers do not limit the number of significant figures in the answer. For example, an exact or a counting number. If I were to say there are 12 or 24 students in this room, that would be a counting number. And exact conversions, like the ones we work with dimensional analysis, are not used in significant figures. So 1 meter is equal to 100 centimeters.